Today we are looking at cycle geometry or cycle theorem. So in cycle theorem, there are various cycle principles or theorems that support each questions. So, and also before you can understand cycle theorem properly, you also need a good knowledge of plane geometry. So plane geometry involves lines and angles. So let's look at the question. For a reminder, we have different theorems in cycle theorems. One, angle in state segments are equal, angles in alternate segments are equal. Cyclic quadrilateral, opposite side is 180 among other theorem. So with that, let's look at the question. So in the diagram below, O is the center of the circle. DA is a tangent to the circle at A. So you should find the values of X and Y. So what is a tangent? A tangent is a straight line that touches a curve or a circle or an arc at a point. You can see this straight line DA touches the circle at this point. That is why they call it a tangent. It's a straight line that touches the circle at a point. So with that, let's analyze what we have from this figure. It is very good you analyze before you think of solving. Now, if you look at the line BA, it passes through the center of the circle. So what does that make BA? It makes BA a diameter. A diameter is a straight line that passes through the center of a circle. So what is the implication of that in cycle geometry? What it implies is that the opposite side of that angle must be 90 degrees. Because for a diameter means the angle here is 180 degrees. So if you apply the principle, one of the theorems in cycle geometry, angle at center is twice angle at circumference. So if the angle at the center is 180, what's not the angle at the circumference? It's simply 180 divided by 2, that will give us 90. So in a simple term, anytime you have a diameter or a line that passes the center of the circle, the opposite side of it is simply 90 degrees. So now that we've got here as 90, how do we now look for the values of X and Y? So if you look at point D, we are given the value there, angle D there as 35 degrees. Like I said, we need a good knowledge of plane geometry to understand cycle geometry. So how do we move this angle into the circle? So to do that, I will consider the principle in plane geometry that says angles, vertically opposite angles are equal. What does this say? If I have a situation, two lines like this angle and this angle, alpha and beta, they are the same. Why? They are vertically opposite. Here and here also, they are also vertically opposite. So if I have here X, here is also X. So what is the point? If you look at this point here, it's similar to the figure we just draw. This angle and this angle, they are the same. The reason for that is vertically opposite. So if here is 35, here is 35, which is synonymous to this diagram I just drew. So let's put that in statements. So let me call here point E. Let me call here point F. Let's call here E and F. So with that, let's solve the question. So angle EDF is equal to angle what? CDA. So both of them is a 35 degree, which is simply vertically opposite angle. If we are to apply the concept of plane geometry, angle EDF is written as angle CDA. Reason vertically opposite angles. That means angle CDA is written as 35 degrees. Okay. So like we said earlier, since here is a diameter DA, it's a straight line that passes through the center of the circle. The angle sustained at the center is simply 180. What about the angle at the circumference? It's now 90. So let's put that also in statement. Which angle is 90? Angle C. So let's classify it. I'll classify it as angle BCA. So angle BCA is simply 90 degrees. Reason semicircle. That is line BA is a diameter. So line BA is a diameter. That means the opposite angle must be 90 degrees. Reason semicircle, which is half of a circle. So remember we are told from the question that DA is a tangent what is the application of that statement in this diagram? So in a tangent, the angle, alternate angle, angles in alternate segments, they are the same. So who is the alternate segment to this angle A? Who is the alternate segment to this angle A? So anytime you see a tangent to a circle, that is the theorem you should apply, angles in alternate segments. So who is the alternate segment to angle A? Is angle B. So if here is X, here is simply X. So but you have to put that in statement by classifying angle CBA is equal to angle DAC or CAD. So angle CBA is something as angle CAD. Both of them is X. Reason, angles in alternate segments. Angle in alternate segments. So if you look at this figure, DCA, we have two values inside the triangle because CDA, DCA is a triangle already. We have two angles already. If you classify this angle, is outside triangle DCA. So what is the implication? This is sum of two interior angles will give us an exterior angle. These two angles, 35 and X, they are inside the triangle DCA. That makes them interior angle. Then this angle C, 90 degrees, is outside the triangle. That makes it an exterior angle. Like I said, that's the principle of plane geometry. Sum of two interior equals to an exterior. So let's put that in statements. So in context, angle D plus angle A is equals to angle C. Reason, two opposite interior angles equals to an exterior angle. That's the implication. So who are the interior angle now? D and A. And angle D is 35 degrees, angle A is X, and angle C is simply 90 degrees. From here, I can find the value of X. Therefore, my X is simply 90 minus 35 degrees. So X will give us 55 degrees. So this is the value of X. So let's calculate the next value, which is Y. We've gotten the values of X already from this figure as 35 degrees. So how do we find the value of Y? So we can actually solve this question in two ways. By applying sum of angle in the triangle BAC, or a tangent to a line is always 90. A tangent to a line is always 90. So that means X plus Y will give us 90 degrees. Alternatively, like I said earlier, sum of angle in the triangle is 180. So either of them will give us the same result. So let's apply a simple theorem of sum of angle in a triangle BA and C. So let's apply the simple concept of sum of angle in a triangle. So we're having angle A plus angle B plus angle C is equals to 180, which is sum of angles in triangle. So what is the value of angle A from the figure? Our A is Y, our B is S, our gotten S already as 55 degrees, our C is simply 90 degrees equals to 180 degrees. So I'm having Y plus 145 degrees equals to 180 degrees. We add 90 to 55. Therefore, my Y is simply 180 minus 145. Y will give us 35 degrees. So that's how you apply the principles of circle geometry and also plane geometry in dealing with questions like that. But let's apply the alternative means. Remember we said a straight line to a tangent will always form 90 degrees. So from the figure we said earlier, it simply means that angle X plus Y will give us 90. Tangent to line. Tangent to line, that means X plus Y will give us 90. So what value of X we got earlier? Our X was 55 degrees plus Y will give us 90. Therefore, my Y is now 90 minus 55. Y will give us 35. So at the end of the day, we have the same result by applying different concepts. So if you like more, want to see more of this video, subscribe and comment.